Hello guys, welcome back to At Home Science. I am sorry I haven't posted in a while. I've been pretty dang busy with school and other stuff, and I haven't had much time to record. However, today is special because this episode is dedicated to some guys guys that have invited me so graciously to their chat to help me out with pyrotechnics and other stuff such. Now, what I'm going to be making today is a compound called copper oxychloride, which might be helpful, but honestly, I'm not too sure. I don't know very much about this compound other than the fact that it's an uncommon form of copper, and it's also used in pyrotechnics. I assume for coloring of copper compound, coloring of the greenish, bluish sparks and fireworks. If I'm wrong, please correct me. I don't know everything. Now, what we're going to need is, first off, copper oxide. Or, well, if you want to skip this step, you can just grab some straight up copper chloride, but honestly, I don't have any of that on hand, so I'm going to have to make it myself. I have 16.3 grams of copper 2 oxide, and I'm going to be combining it with about 45.5 milliliters of hydrochloric acid. That's a bad idea. I am going to be mixing the acid to... Oh, there's a little bit still in the speaker when I measured it. I'm going to be mixing this acid to the oxide first. I should probably set up my fan. Give me one moment. Now the reason I'm doing this is because it might not be in proportion. I am not thinking straight, trying to do two things at once. I am sorry. It just is not. Wind power! Blow the acid away from my face. Thank you. Now, sorry about the fan's just right there. You look, camera over there. Forget it. Anyways, this is going to make copper chloride. This is extremely impure copper oxide. I will note. It's just gonna let you watch as it mixes. I'm going to add slowly so the production of carbon monoxide or chlorine gas, if any, is slight. And I'm going to be careful, gentle. Mix thoroughly. Now the dark green color, which you see, is copper chloride. Though there are impurities, as I have noted in the past. This is mainly because I am working at my garage, and this is exactly the same place where I made this copper chloride. It is full of contaminants that I honestly don't really know much about. Look at that pretty color. Don't you just love... This is why I love chemistry. It's so pretty. It's so pretty. Let me just add the rest of the acid and let it to boil and bristle like a witch's cauldron. Get the rest of this dust out. And then I shall carefully mix... Oh dear. See, look at me. I'm informal as heck. I'm probably going to die within the next 20 years. Now we have our very concentrated solution of copper chloride. As you can see here. How good does that look on camera? You want to see? Look at that pretty color. Copper is honestly a weird color. Yeah, there's a whole bunch of contaminants at the bottom of this. So what I'm going to do, I am actually going to let this sit off to the side right here, and I'm going to decant it in a second. But while we're waiting for that to go, we're going to prepare the second step of the reaction. This is two-part. Well, two-part considering you have to make the copper chloride first. But if you have copper chloride and it's pure, use that. I just wanted to use this so I know what concentration I have. The second part is making a solution, around a 1.6 molar solution of potassium hydroxide. This is because the potassium hydroxide is used to add on a few oxy groups to the copper. Am I wrong? I probably am. I don't know everything. I'm an amateur chemist with barely any time or money or food. I lost my train of thought. One moment. Fan? Okay. This is because the production of the copper oxychloride needs a more basic solution in order to form over the side products which this reaction will create, which is more copper oxide. That is something we do not want. So we are going to make an over solution of 1 molar of potassium hydroxide solution. Please be cautious. Am I doing this just all wrong? I think I am. Oh boy. Please don't blow up my hands. Please don't blow up in my hands. Please don't blow up in my hands. Okay. I don't know why I chose this specific container. Also, look how tiny this glass stir rod is. Come on. I can barely afford anything rather than this. I gotta get all the leftover in this glass bowl and get it out. There we go. Now, while we're waiting for this, we have to chill the reaction to at least 20 degrees Celsius. Now I think about it, I forgot my thermometer. Oh well. This is an ice bath. And this is our copper chloride solution. Oh boy, man, there's a lot of nonsense in this. I need to go filter this. I'm going to need to filter this off. If you will be patient and wait for about 30 seconds, I will be right back. I need to grab a funnel paper and a funnel, because let's see if I can get this on camera. Can you see all that? Look at this. Can you? Let's see. There. How's that? Can you see? Maybe? Oh dear. Well, anyways, I'm gonna let that to chill. The reaction. Oh gosh, your focus. Camera. Focus. Focus, will you? There we go. This is an exothermic reaction, meaning it lets off a lot of heat. I will be back for about 20 seconds. Count me. Okay? I'll be right back. I am back. I'm sorry for the wait. Was that more than 20 seconds? I bet it was. Now, let's... Fan, be cooperative. Fan. Okay, fan, you can stop. Okay, let's get all suspended and pour that nonsense through. Yeah. There's just all kinds of glass bits and organic material in this. However, this is crystal clear. I just need to let it filter for the time being. And, well, this is a much longer video than I was hoping, but I guess I can take the time to explain how this works. And I shall do this if I can angle the camera properly. Camera, work with me. Okay, you're gonna see some real amateur photography here. So the initial reaction of copper oxide plus hydrochloric, oh crap, you cannot read that. Yeah, come on, camera. Okay, so the initial reaction is copper, focus, copper oxide plus hydrochloric acid, which yields copper chloride plus water, which is H2O. And in order for this to be correct, you need 2 moles of hydrochloric acid per copper oxide in order for the reaction to be complete, since there's only, 1 chloride ion, 1 copper ion, one oxygen there, and then two hydrogens there. Equation is balanced. Now, just move the camera over physically. Now, we take this, copper chloride solution that we just made, and we react it with the solution of potassium hydroxide. We get, where's my cheat sheet? Un momento, I need to get my cheat sheet. Ah, there it is. See, look, here's a script. You don't get to see it. Now, what we get is our copper chloride, copper oxychloride ion, which, well, actually, no, it's not an ion, it's insoluble in water. Sorry for the confusion. Plus some potassium salt. Now, we need to balance this equation, and I believe it is as follows. That is a crappy marker. I am sorry. What in the world? Oh, it's a 2-in-1 pen. What do you know? The more you know. Wait, it's a 2-end pen. Anyways, that's not helpful. So that's the reaction we're going to be taking place, which actually will be sooner than you think, because look, our solution has filtered most of the way. And we can begin our ever-enduring reaction by first getting rid of this, and instead replacing it with not this. You know what? We'll do it in the little flask. We'll put the flask in the chiller, and we'll take out the nastiness. And I'm impatient, so I'm going to squeeze out whatever I can. That is a pretty color. I said that before, I know. Now let's take a look at what was in that. Oh gosh. Ugh. Make me want to throw up my throat. That is going to the atomic plant to burn. Now let's remove my little funnel. Just put that over here. Please don't break. I already broke like 4 of them. Just shh. There. Perfect. Now, our solution of potassium hydroxide is all clear. Now, this is the part where I get a little iffy because I honestly don't know what to do to this point. I've been told in a few different ways to do this, to mix it slowly and to mix it fast. From what I know, the best option is to mix it fast here. Don't quote me on this, please. But from what I've read, and I've tried looking on various sources to find out, but I've heard contradicting stories on similar sources made by the same author. Don't get mad at me for that. I'm sorry, but that's the truth. That's what I saw. We have our copper chloride solution right here, and it's been properly chilled. And we're going to add it to the potassium hydroxide solution and watch the magic happen. That is a horrible shot. I am sorry. Come on. You know what? We're going to move you closer. And focus the camera. Maybe. There we go. Oh yeah, special shout out to Home Science Tools. Sponsored, hashtag sponsored, hashtag maybe not sponsored. Actually, no, I'm not sponsored. I'm too young. Now, copper chloride solution, as it goes in, all at once. Look at that. That's our precipitate right there. And we mix it fast, and it'll turn light bluish, if I'm not correct. And there's still left over in the beaker, so what we're going to do is mix these two liquids. There we go, and after a quick moment in the chiller and a quick flash of the camera, we are off to the races. this will be a tedious process. And of course, some of the copper oxychloride is going to get through. It is still super fine particles. However, most of it will be caught. No, not all of it. And here's some that I've made previously as a little test to see if it'll work. And well, sure enough, it works. That's well, pretty much all I got for today. I will check back with you in a few minutes, in probably a few. I actually don't know how long it'll be until I make a next video. I mean, I gotta still edit this one and yada yada yada. But before I talk for long, please keep up with me on my social media. I have an Instagram. It will be pyroman something something something. I'll probably leave a link in the description to my Instagram channel. I don't really know what to call it. I may be young, but I don't know the internet that well. I know chemistry. I know physical objects, not the internet. Technology. Why? Oh well. Well, this has been my little video how to make copper oxychloride. I hope it's been helpful. Really do. I tried doing my best with what I knew. But in the end, all I got was... but whatever. Hope I'll see you guys next time, and don't catch yourself on fire. Please. Oh, and always remember, don't ever... fan power! Oh well. Don't you just love your fans? I do. But that's not... I'm saying but too much. I'll see you all next time. I am so sorry about that. I don't know what happened. The camera just kind of cut out. I think it lost power. Alright, after technical difficulty, this is what we have. This is our less than beautiful solution of copper oxychloride. Or at least it should be. I mean, I'm not a rocket scientist. I'm an amateur chemist. This is the best I can do. But, I mean, it worked pretty well for first attempt. However, this did not go really as well as I wanted to. For example, we still have this nonsense to deal with. But it's all about the learning. I'll give this a few seconds. It's gotten quite warm actually. Give it a chiller. And if you'll excuse me for another 20 seconds, I will get another set of filter paper and we'll filter right here, right now. I will clean out. I probably get my bigger flasks so we don't have to worry about overfilling. But just excuse me for one moment. I will be right back.